Good day to all who are with us in this Air Center Networking Friday on Coastal Observation and Modeling Systems in Brazil. We have two parts in this network. One is this Friday, and the second part the next Friday. And each of them will have 7 speakers. The speakers will talk about their studies and research during 10 to 12 minutes. And at the end, we have time for questions, comments, and interactions. The first of them, it's Carlos Lentini. Carlos Lentini is substituting our colleague André Lima, that is in a reaction from the vaccine, and he's well, but is not able to attend today. And Carlos Lentini holds the BSc in Oceanology from the Federal University of Rio Grande, master degree in Physical Oceanography from Oceanography Institute of São Paulo University, and a PhD in Physical Oceanography and Meteorology from the Rosenthal School of Marine and Atmosphere Science at University of Miami. He is a faculty member at the Department of Earth and Environment Physics and at the Federal University of Bahia. Please, Carlos, 10 minutes.
Okay, thank you so much, Segen, for the introduction. Let me share my presentation with you guys. Okay, I hope you guys are seeing my presentation, okay?
Yes.
So the title of our project is Detection, Control, and Preventive Remediation of Oil and Fuel Transportation and Accidents off the Brazilian Coastline. Here we have a list on your right-hand side of our team members. And here at the bottom, you can see their respective affiliations and also the sponsors. The BR Oil project has basically like 2 phases so far. Phase 1, which was an addendum to an emergency call from the Ministry of Science and Technology and Innovation due to the 2019 oil disasters that happens here on Brazilian coastlines. And phase 2 is, I'm sorry. And phase 2 is the result as an open call from CNPq and MCTI last year. So for the phase 1, we have basically like 2 pillars, the remote sensing detection and the oil spill modeling. While on the phase 2, we have also the same, 2 phases for the same 2 pillars from phase 1. And we added this part that, estimates the biological doses concentration. If you have like, suppose that you have like an impact on marine biota. So according to the first pillar, which is the remote sensing detection, we developed an algorithm, it's called RIOS, which stands for Radar Image Oil Spill Seeker, which is an autonomous system for detection of oil leaks on the ocean surface based on artificial intelligence and neural networks. And so far this algorithm is running for Sentinel-1 satellite images. Here you have in this flow chart the basic structure of this algorithm. And on the right-hand panel, you can see that this hatched area here represents the seeking region, the searching region, which right now it goes from the equator to 23 degrees south and from 49 to 24 degrees west. However, we can change, the size of this searching area. We can extend it or expand it, or you can just contract it, depending on our interests. So how did we manage to get, to this RIOS algorithm? We tested 42 attributes, and according to the results of this fancy correlation matrix, we selected the 11 most relevant ones. And so what's the output of this algorithm? So here you have an example for 3 targets for oil, winds, and rain cells. On the shaded gray images is the radar images in decibels in sigma naught, and the color maps represented the oil probability maps. Warmer colors are related to higher probabilities, whereas cooler colors are related to low probabilities. So far, our algorithm has an accuracy of up to 90% for oil detection. So the algorithm is running on this region here, on the right, your right-hand side. So if it finds an image that has a high oil probability, it sends us an email to all the BA oil members. And at the same time, it selects all the forcing fields from the Copernicus Marine Service model outputs. So then we can move on to the second part, the second pillar, which is the numerical modeling part. So with these forcing fields, we force our numerical model. The output of this model will feed the oil dispersion weathering model together with his specific characteristics of the oil. And the outcome of this model will be that we have a forecast for oil spill transport and transformation. So we did a simulation for the 2019 incidents. We selected all these color dots using these forcings here, I'm sorry. And then we can see that for the red dots, they indicated oil spills that did not reach the shore. In magenta, oil spills that reached the northern coast of Pernambuco up to the extreme northeast of Rio Grande do Norte. In black, oil spills that hit the southern coast of Pernambuco, which was the first region that actually had the spill that was reported. And then in green, the oil spills that reached the northern coast of Alagoas up to the southern part of Pernambuco. So the third pillar is to estimate, the biological dose concentration. So imagine that you have, this oil will reach the coast, will affect the biota. So then we use, another model to estimate those concentrations. We all know that crude oil is toxic due to its chemical structure. In its nuclear composition, we have nuclides that are, basically composed of uranium and thorium series. So the International Commission on Radiological Protection, ICRP, evaluated the effects of exposing animals to this kind of radiation. So with this model, we can estimate the changes in population size or structure, early mortality, morbidity, reproductive capacity, and chromosomal damage. So how it works? We select, from this ICRP reference protocol, we select basically 3 species: flatfish, crab, and brown seaweed. All these species are representative for the areas that were affected with oil, according to the 2019 incident. We exposed these species to uranium and thorium series of radiation, and then we applied them to the MCNP model, which stands for Monte Carlo N-particle, which we estimated those conversion coefficients for both these uranium and thorium series. And as a result, we can have strategically access the maximum exposure time for emergency oil control, removal, and mitigation. So here is the bare oil production. We have so far 4 papers published. We have here also the one in Frontiers and in Marine Science. And thanks to Guilherme, José Moutinho, and Maurício Neuberg that invited us, to contribute to this paper. And we have 3 more submitted that are just waiting, for the outcome. Thank you so much for this time, for your time, and for this opportunity that you guys gave us. Here's my contact. Thank you so much.
Thank you very much, Carlos, for your nice presentation. As I mentioned before, we will have time at the end for questions and comments. Those interested must put your questions in the Q&A box under the screen, in the bottom of the screen. Okay, now we move to the second presentation by Karina Bock. Karina holds a degree in oceanography from the Rio de Janeiro State University, a master's degree in civil engineering, and a doctor of science degree also in civil engineering at COPPE, Federal University of Rio de Janeiro. She is a researcher at the Laboratory of Computational Methods in Engineering and at COPPE, mainly in physical oceanography, focusing on computational modeling, oceanic climate variation, climate change, and analysis of meteorologic and oceanographic data. Please, Karina, your presentation.
Let me see. Okay, good morning. I'm here today to talk about one of the projects of the LANCE, and this project is called Bahia Viva. In it, the Guanabara Bay, it surrounds our objects of study, and Guanabara Bay is a coastal water body located in the state of Rio de Janeiro, Brazil. Due to its strategic location and the importance of economic activities developed in its interior and surroundings, understanding the environmental and social aspects that govern this coastal bar becomes essential. The Bahia Viva project has as a main goal, the development, let me see. 1 minute, please. Okay. The Bahia Viva project has as a main goal the development of an operation and digital platform for the provision of environmental, social, and economic information in and around Guanabara Bay. And the information generated comes from different sources, such as historical databases, in situ and remote data acquisition platforms and numerical models. The digital platform is freely available, and the project aims to attend demands in different sectors, such as environment, mobility, health, education, and others, seeking alignment with the United Nations Sustainable Development Goals. The project has the partnership with, of other institutions, and the project represents a pioneering effort associated with the regional initiatives of the AirCent and has been funded by FAPERJ since 2019. Remote and local data platforms are used to monitor or measure in real time the marine and atmospheric conditions of Guanabara Bay and its surroundings. And all these data and numerical results are obtained in the project are presented through the Bahia Viva website. Currently, a meteorological station located in the Technological Park of Federal University of Rio de Janeiro is used to measure atmospheric data such as precipitation, wind direction and intensity, relative humidity, and all this data is transmitted in real time. Other equipment can be installed on this region, such as a digital marine thermometer or acoustic profiler, increasing the volume the volume of measured data. In addition to data, to in situ data, information obtained from a meteorological radar and data obtained through remote sensing, such as color composition and convective systems, are available on the website. And the remote sensing data is obtained via LANCE's own environmental satellite receiving antenna. And the metadata are used not only to the creation of a historical observation information, but to evaluate the results of the numerical models used on the project. Here, the project has an operational forecast system with a high resolution, high spatial and temporal resolution for Guanabara Bay. The forecast horizon of the model is 2 days, and all models are executed operationally, generating forecasts for conditions of surface marine currents, winds, wave, and the operational forecast system is updated daily on the website, and hourly information is provided. The results for the current day are presented on the website in the form of spatial distribution fields. In the atmospheric modeling area of the website, the results of wind speed and direction at 10 meters, air temperature, cloud cover, and precipitation for entire Guanabara Bay are available. And the model used is the WRF. There are 4 nested grids. The one with the highest spatial resolution have 1 kilometer for entire Guanabara Bay. And there are 30 vertical levels, and the initial and boundary conditions are obtained from GFS. Fields of direction and intensity of marine currents, surface marine currents for the entire Guanabara Bay and Technological Park area are presented on the website. To generate these results, the model uses the ROMs. In the system, 2 nested grids, 2 numerical grids are used, and for the Guanabara Bay area, the spatial resolution is 200 meters. The model has 20 vertical levels, and the initial and boundary conditions of the lowest resolution grid are obtained from Copernicus, and the forcings are the operational results of atmospheric model and tides. To represent possible integrated application of different numerical models, an oil dispersion model was also implemented for the region. In it, the results generated through operational atmospheric and hydrodynamic modeling are used as forcings to simulate an hypothetical accident in the Guanabara Bay, in which there is a continuous oil leak at a rate of 100 tons per hour. And maps of trajectory of the oil leak on the water surface and of oil retention along the coast produced from the results of the oil dispersion modeling are also generated and operationally updated. This type of system and result can be used, for example, to provide information and predictions about the behavior of an eventual oil leak quickly and practically without human intervention, minimizing the response time for decision making, for actions of control and mitigation of accidents. This one model is used for wave forecast. The grid used has 100 meters of spatial resolution, and the boundary conditions are obtained from the results of a 6-kilometer grid, numerical grid of the Wave Watch model. The model temporal resolution is 3 hours, and the significant high and wave direction fields for the current day are presented on the website. Through the results of the wave modeling, the wave power for the region is calculated, demonstrating the application of these results to, for example, projects that aim to provide then the potential of waves as a way to produce clean energy. The project's website also has social, environmental, and health data for the region. On the website, there is a division in Bocaina region, metropolitan area of Rio de Janeiro, and mountain region, and others. And for each of the regions, there are specific data. And for example, for Bocaina region, there are atmospheric and wave results from operational model, and socioeconomic data and social indicator are presented for each region. And this is a dynamic part of the site in the sense that new information can be made available as it is acquired. In the near future, other data and solutions will be added to the Bahia Viva project website. In 2020, this project served as the basis for the proposal of a project in UFRJ. The goal of this project is to add digital solutions to this platform, which allow the modeling of the epidemiological dynamics of COVID in the metropolitan area of Rio de Janeiro. And human mobility and hospital equipment tracking will be added, which integrated with social and environmental data will serve for the development of a regionalized epidemiological model. And the project this project was proposed by COPPE and has the participation of researchers from LNCC, FGV, and Fiocruz. And other initiatives can be included on the website. In addition, the monitoring and forecasting in this project can be replicated and implemented in any coastal environment, generate information that can benefit different sectors, such as those associated with environment management, mobility solutions, health, recreation, among others. This concludes my presentation. Thank you all for your presence and participation. Thank you.
Thank you very much, Karina, for the interesting results from the integrated platform for Guanabara Bay. It seems to be an important tool to be expanded in the near future. Thank you very much. The next speaker will be Dr. Paulo Nobre. Paulo Nobre has a BS in meteorology from University of São Paulo, master's degree from the Brazilian National Institute for Space Research, PhD in meteorology by the University of Maryland, and a postdoc on oceanography at Columbia University Lamont Doherty Earth Observatory. He was the former coordinator of the Brazilian Network for Climate Change Research, Rede Clima. Currently, he is the Brazilian coordinator of the Brazil-France-US Pirata Project, the coordinator of the development of the Brazilian Earth System Model, and he also teaches at INPE, that is the Institute for Spatial Research in the graduate program on meteorology. Please, Dr. Paulo Nobre.
Thank you, Segen. It's a pleasure to be with you all here. And I will change gears lightly and talk about the effort that we have done and we are doing in Brazil to develop our own capacity to do Earth system modeling, and linking this capacity on climate change and oil spill. So as we know, climate change is a greatest challenge.
Paulo,
so
we are not seeing your screen.
You are not seeing my screen.
Yeah.
You are sharing. I will stop sharing. I will stop sharing.
Share again. Yeah.
Share. Share. Says here that I am sharing my screen. Are you seeing my screen? No?
I can't see it, but or the colleagues can see? No, I don't think so.
No, sorry, Paulo, this is José Luis. Maybe if you could close your PowerPoint and then open it again, sometimes you should another window. Just to give a try.
Close my PowerPoint.
Yeah, your presentation on PowerPoint, and then try to find and then make the presentation.
Yeah, but you are not seeing my screen, right?
No,
Okay.
we're not seeing your screen. But here we see that you start the screen sharing, but we cannot see your screen.
Yeah.
Okay, I closed my PowerPoint presentation.
I will stop your sharing and then try again, please.
And stop sharing.
Exactly.
Stop sharing.
And then now choose your presentation. This sometimes happens when you have two screens. Probably we have two screens.
If it doesn't go this time, I will ask that Segen, you ask the next speaker.
Okay.
And Paulo, please send me your presentation and I can pass it to you. So we move to the next presentation. We have any problem, and then I will pass the presentation for you. Is that okay?
I have my screen again.
No, we cannot see it.
Yeah. Okay.
It's like close.
Yeah. So Paulo, send me your presentation, please. So I can share, okay? Okay. And then we could move to the next one. Then we go back to Paulo.
I move to Guilherme France, please. Professor Guilherme France has a PhD degree in environmental engineering with emphasis on numerical modeling of coastal systems from Instituto Superior Técnico, University of Lisbon, postdoctoral researcher at the Center for Marine Studies from Federal University of Paraná. Presently, he is the technical coordinator of the Brazilian Sea Observatory. Please, Guilherme, I think if you prefer to speak in Portuguese, feel free to do that.
Ok, obrigado, Segen, pela introdução. E eu gostaria de agradecer também ao Air Centre pela organização desse evento, com a abertura desse espaço para a apresentação de algumas iniciativas brasileiras voltadas à observação e modelagem do oceano e sistemas costeiros, proporcionando assim o debate de como essas iniciativas podem ser conectadas e novas iniciativas fomentadas para preencher as lacunas da cobertura de monitoramento na extensa costa brasileira, otimizando recursos e também o retorno dos investimentos para a sociedade. Essas imagens exemplificam um pouco as consequências do lançamento de poluentes, como óleo, efluentes industriais e lixo no mar, com graves consequências, graves impactos ambientais e risco para a vida de espécies marinhas, e também impactos socioeconômicos para atividades como pesca, aquicultura e turismo. Além disso, as alterações climáticas têm aumentado a frequência dos eventos extremos, aumentando o risco de inundações costeiras e obrigando as autoridades e gestores públicos a reavaliar o planejamento das cidades localizadas na zona litorânea. As observações e previsões do oceano, elas são essenciais para ações de planejamento e mitigação, de forma a reduzir esses impactos ambientais e socioeconômicos. As previsões de modelos operacionais, elas nos permitem antecipar esses eventos extremos e prever a trajetória de poluentes lançados no oceano de maneira acidental ou proposital. E a disponibilidade pública de informações sistemáticas em tempo real, tanto de bacias oceânicas como mares regionais e sistemas costeiros, é fundamental para o desenvolvimento sustentável da chamada economia azul. Envolve uma gama de setores da economia com atividades relacionadas ao mar e também a criação e aplicação de políticas públicas voltadas à conservação do oceano. Os modelos numéricos, eles nos permitem uma visão geral para uma melhor compreensão da dinâmica marinha, considerando os diferentes processos oceanográficos e a influência das condições meteorológicas e das descargas de rios. Os modelos, eles permitem extrapolar a informação pontual dos dados e, além disso, realizar previsões. Mas os dados e os modelos são informações complementares. Nós precisamos dos dados para a validação dos modelos e também podemos utilizar dados para assimilação nos modelos e melhoria dos seus resultados. O Observatório Brasileiro do Mar, ou BSO, a sigla que vem de Brazilian Sea Observatory, é um protótipo de um serviço de monitoramento costeiro, que inclui um sistema de modelagem de alta resolução para a costa do Brasil e uma plataforma WebGIS com o objetivo de integrar essas previsões com dados in situ, observações de satélite, posições de navios e também conta com uma ferramenta para a previsão da deriva de poluentes como óleo de maneira online. O utilizador pode fazer essas simulações dentro da plataforma. Esse é o site do BSO, pode ser acessado brasilianseaobservatory.org, e nesse site pode ser acessada a plataforma WebGIS. Esse projeto teve início, essa iniciativa começou com o apoio do Copernicus Marine Service, ou CMEMS, que é o Serviço Europeu de Observação do Oceano, e foi coordenado, teve o desenvolvimento coordenado pelo Centro de Estudos do Mar da Universidade Federal do Paraná, com o apoio do grupo de pesquisa Maritec, do Instituto Superior Técnico da Universidade de Lisboa, que é um grupo que tem muita experiência no desenvolvimento e aplicação de modelos numéricos, e também contou com a colaboração da empresa Invex, de Engenharia e Consultoria, que nos ajudou aqui no desenvolvimento da plataforma WebGIS. Na plataforma é possível observar as previsões de modelos globais, que vêm do CIMENS, obtidos da base de dados do CIMENS, e dos nossos modelos implementados dessa iniciativa do BSO, com um foco inicial para a costa, para essa região que vai de Santa Catarina ao Rio de Janeiro, um detalhe maior para as costas dos estados do Paraná e Santa Catarina, incluindo modelos de alta resolução para sistemas estuarinos locais. Esses modelos são tridimensionais e essa abordagem de downscaling, obtendo as condições de fronteira aqui do modelo global, nos permitem resolver processos de diferentes escalas espaciais e temporais, como, por exemplo, considerar eventos meteorológicos extremos que ocorrem a centenas de quilômetros da costa e alteram o nível médio do mar. A ideia é expandir esses modelos de alta resolução para outros sistemas estuarinos ao longo da costa do Brasil, em parceria com grupos locais, então, de uma maneira colaborativa. Dentro dessa plataforma, nós definimos uma área que o utilizador pode fazer simulações da deriva de óleo, então, clicar num ponto, definir uma data e vai ter uma simulação hoje está definido para 2 dias à frente, em 1 ou 2 minutos, vai ter resultados, e dependendo da área que o utilizador definir, né, selecionar, vão ser utilizadas as previsões dos modelos de maior resolução, como, por exemplo, aqui para o estuário, para o complexo estuarino de Paranaguá. Dentro dessa plataforma, também estão disponíveis observações de satélite, como de clorofila, e de boias oceanográficas que estão à deriva, para visualização tanto em mapa como em formato de gráfico. E essas informações hoje vêm do CIMENS, desse serviço europeu, mas nós temos a intenção de incluir dados de sistemas brasileiros de monitoramento costeiro, como, por exemplo, o Sincosta e outros grupos, de uma maneira que seja, que essas informações estejam integradas numa plataforma e sejam de fácil acesso para qualquer utilizador poder visualizar de maneira rápida esses dados e comparar, por exemplo, com previsões de modelos, com resultados anteriores de modelos. A ideia aqui é ter informações em tempo real e dos últimos dias, de um ponto de vista operacional. E também temos a intenção de incluir uma componente de ciência cidadã, incluindo imagens buscadas em redes sociais, vamos desenvolver uma ferramenta para buscar essas imagens em redes sociais, como, por exemplo, com áreas afetadas pelo derramamento de óleo, e assim fornecer informações para dar dimensão de incidentes, como o que aconteceu na costa do Nordeste em 2019, e para que autoridades possam tomar ações de uma maneira mais rápida, sabendo as dimensões do problema. O BSO ele foi lançado em um workshop que também teve o objetivo de discussão do papel dos observatórios costeiros no Brasil e no mundo, e contou com a participação de diferentes setores da sociedade, como Ministério Público, órgãos ambientais como IBAMA, Secretaria de Estado, empresas como Petrobras e agências portuárias, e também com a participação da academia, de universidades de diferentes regiões do Brasil. E teve a apresentação aqui, por exemplo, do Carlos Garcia, sobre o Sincosta, da Janine Pereira, sobre a REMO, a Rede Brasileira de Modelagem Oceanográfica, o Luiz Garbosa, sobre a Rede de Marégrafos de Santa Catarina, e o José Moutinho aqui falando sobre o AirCentre. Esse evento teve uma grande repercussão midiática, demonstrando a importância da sociedade, para a sociedade desse tipo de iniciativa. A partir das discussões desse evento, teve origem um artigo que contou com a colaboração de pessoas de diferentes instituições ao longo das diferentes regiões do Brasil, e nesse artigo são discutidas algumas das iniciativas existentes no Brasil de observação e modelagem, e também as perspectivas futuras. Então, algumas propostas são dadas, como o desenvolvimento de uma rede integrada de observatórios costeiros, que poderia contar com o apoio do futuro Instituto Nacional do Mar, e ter a criação de associações regionais para facilitar a comunicação, a colaboração com entidades federais, e também para o engajamento de stakeholders locais, como comunidades locais, tomadores de decisão e gestores públicos. Esse artigo ele foi aceito para publicação na revista Frontiers in Marine Science, e o abstract já está disponível. O link para esse abstract está disponível no site do AirCentre, desse evento, e vocês podem se inscrever para receber a notificação quando o artigo for publicado. E esse artigo inspirou esse evento de hoje, do AirCentre, e da próxima semana. Então, algumas das iniciativas que estão sendo apresentadas aqui estão contempladas nesse artigo. Então, o BSO nasceu com o apoio do CIMENS, e nós conseguimos também agora um apoio da Marinha do Brasil. Esse apoio do CIMENS era apoio de 2 anos, já terminou. Agora temos um apoio da Marinha do Brasil dentro de um edital do CNPq e do Ministério de Ciência, Tecnologia e Inovação para combate ao derramamento de óleo. Então, nesse projeto, nós vamos expandir os sistemas de modelos de alta resolução para outras regiões do Brasil, em parceria com grupos locais, e também incluir uma ferramenta de detecção de óleo por imagem de satélite, que vai dar a condição inicial para o modelo de trajetória de óleo. E nós estamos em busca de mais financiamento de outros projetos para continuar o desenvolvimento da plataforma e do sistema, incluindo modelos de bacias hidrográficas para gerar previsão de vazões de rios, que é uma grande incerteza que nós temos hoje, e com isso melhorar a previsão da dinâmica costeira, e também desenvolver a plataforma, o sistema, para elevar o grau de maturidade da solução e conseguir, assim, no futuro, um financiamento de longo termo, financiamento sustentável de longo termo, e que poderia contar com apoio para essa finalidade do futuro Instituto Nacional do Mar, criando assim uma rede de colaboração, uma plataforma que fosse colaborativa para a divulgação dos diferentes sistemas de monitoramento costeiro no Brasil e dando suporte para a sua continuidade. Eu já trabalhei em outros projetos para desenvolvimento de plataformas e sistemas e já vi vários outros projetos que começaram, mas com o final do financiamento, essas iniciativas acabam, então isso que eu não gostaria que acontecesse nesse caso. Então, estamos em busca de mais apoio e para ter no futuro um financiamento de longo prazo e que poderia contar também com o apoio do AirCenter, pensando que o AirCenter tem esse papel de criação de redes, aproveitando infraestruturas existentes, e também essa plataforma, que a ideia que é de código aberto e tem ferramentas, modelos também que são de código aberto, poderia ser replicada para outros países, para outras partes do Atlântico, como para o continente africano. Então, é uma plataforma que poderia ser replicada com apoio do AirCenter para outros locais no Atlântico. Com esse apoio da Marinha, nós temos iniciado uma parceria com outras instituições, outros sistemas, como a REMO, Rede de Modelagem e Observação Oceanográfica Brasileira, Universidade Federal da Bahia, Universidade Federal do Pará, CIMEPAR e EPAGRE, que são empresas públicas, institutos de meteorologia, e a ideia é aumentar esse número para ser realmente um observatório brasileiro do mar. Então, tem instituições em todo o Brasil. E estamos em busca também de parceria em outras áreas, como, por exemplo, informática, para nos ajudar no desenvolvimento da plataforma ABGIS, criando uma plataforma mais eficiente e comportando as novas informações e desenvolvimentos. Então, para concluir, o nosso interesse do BSO é dar apoio a atividades de pesquisa, então fornecendo informações que podem ser utilizadas por pesquisadores de diferentes áreas, como, por exemplo, quem trabalha com biologia marinha ou química poderia se beneficiar dessas informações sobre as correntes, salinidade, temperatura que temos na plataforma. E, no futuro, queremos incluir modelos de qualidade da água, incluindo aqui o ciclo dos nutrientes, do oxigênio, do fitoplâncton. Dar apoio também à conscientização da população e educação sobre processos oceanográficos. Então, é uma plataforma que a ideia é ser de fácil utilização por qualquer pessoa, não precisa ser, então, uma pessoa com alto nível de especialização para utilizar a plataforma. E assim, as pessoas podem visualizar os processos oceanográficos que estão ocorrendo no momento e na sua região. Então, isso pode facilitar o processo de educação e de conscientização, dar apoio a atividades de planejamento e operacionais, como navegação, atividades portuárias, óleo e gás, aquicultura. Então, a ideia é chegar no nível que essa plataforma possa ser utilizada de forma operacional e dar apoio para essas atividades para evitar acidentes e mitigar os impactos de eventuais acidentes. E dar apoio a ações de planejamento e mitigação para reduzir os impactos ambientais e socioeconômicos. Então, essas informações poderiam ser utilizadas por gestores públicos, agências ambientais, a Marinha do Brasil. A plataforma, a ideia é ter uma visão geral, então, dos efeitos de poluição, não estudar a poluição pontual, mas sim os efeitos do lançamento de poluentes de forma global, e também a ideia é disponibilizar os resultados das nossas previsões para download, não apenas para visualização, para que as pessoas possam explorar os resultados, fazer análises e até implementar novos modelos, fazer o downscaling, implementar modelos com maior resolução para uma determinada zona, para um determinado porto, por exemplo, e esses resultados poderiam ser utilizados por empresas, empresas que desenvolvessem novos produtos e serviços para um cliente específico, assim, incentivando o desenvolvimento da economia azul. Então, gostaria de agradecer pela atenção, deixo aqui o meu e-mail para quem tiver interesse, tiver alguma dúvida, pode entrar em contato. Obrigado.
Thank you very much, Guilherme. We should emphasize that the paper that you lead and coordinated was very important and motivated these two events, today and next Friday. The Coastal Ocean Observing and Modeling Systems in Brazil, accepted in Frontiers in Marine Science. And everybody is welcome to this paper, and the group, especially Guilherme, I'm sure is open to discuss it further if necessary.
Of course. Thanks, Segen.
Thank you very much, Guilherme. Now we come back to Dr. Paulo Nobre. I think the presentation is fine.
Oh, okay.
Okay.
Thank you. Thank you, Segen. Sorry for the technical issue. As I was mentioning, I will change gears a little bit and tell about the efforts that we are undertaking in Brazil to have a capacity to predict weather and climate phenomena on large and long time scales. So this is a development funded by the Ministry of Science and Technology, COPPE, FAPESP, FINEP, National Institute for Climate Change, and lately by the Brazilian Navy through CNPq call for proposals of 6/2020, and the Comtech Paulo Secretary, through which this. So the idea here is to encompass and give a backward information on how do we model the ocean and the atmosphere on large time frames. The next picture, please. So why we need to have a global climate model in Brazil? So because the extremes are happening, up until 2019, we were looking at climate change global effects on Brazil. And not kind of, the next slide will show that is the problem of oil spill. So this is another natural, not natural, but a phenomenon, a great disaster that affects people and the environment enormously, in which we can benefit for having this capacity for modeling capacity. Here we have one, not the next, please. You click to appear the text. Yes. So the costs are unbearable for kind of disasters that we had in 2019 that can happen again. The next, please. Monitoring the whole Blue Amazon is needed. We need to have a smart way of monitoring and predicting. And the next, one more. So we too fast. Yeah, thank you. And so we need to use state-of-the-art observation from space, forecasting systems, and we have seen three projects already presented that deals directly with this question of detecting and predicting. And I will show at the end that monitoring and predicting is not enough. We need to dissuade somehow that this is not going, it is man-made. So before going that, let me show you next slide a little bit of something that maybe would not be present in a coastal, the challenge that we have. Click one more, please. It is to build this model in Brazil. And this is not something small. So what's the challenge is to incorporate knowledge that is particular for the South Atlantic and the South America and Amazon, the blue and green Amazon. And in the beginning, it was that we want to mitigate and adapt to climate change, not only, but having a new generation of scientists that can model, that can predict their system. Next, please. So then we came with this one model that we use to predict weather and climate from 20-kilometer resolution days to months and seasons and millennia. That is operational today at INPE. Next slide, please. And here is the conceptual, what is the Brazilian Earth System model? It's a composition of modules, one model for the atmosphere, the Brazilian Atmospheric Model, BAM, one model for the ocean. Today, our latest version of our model uses MOM6 from GFDL, and a land model, in addition to a chemistry. These three models here are already coupled. We are working on coupling a NCAR chemistry model into this Earth System model, which are linked through a coupler that take the flows, energy, mass from one model to the next. Next, please. And then comes a little bit very technical, but please, one more and more. That is how we actually do it, how we run for 1 day, 1 month, 100 years. So we have initial conditions, and these models provide the data they need to the coupler, and the coupler distributes this, and we do it hourly. So we describe the diurnal cycle well, and this product, eventually next, please, one more. They will, one more, be given to keep clicking one more maybe, to a regional model. With coupled simulation, I will not talk about this now, but next, please. A couple, yeah. We give it this global data to a regional high resolution atmospheric, and we are now coupling to a regional ocean model that produce the high resolution, what Guilherme just mentioned before, products that can be used in several applications. Next slide, please. And once we produce such a kind of model, we need to know whether it reproduces the natural modes of variability of their system. So for the Atlantic, the dipole temperature is one important for climate predictions. And the left is our observation, joint EOFs of temperature and stress. And the right is what the model produces running freely. It's a fully coupled. So the model reproduces the main modes of variability. That is the message in this slide. Next, please. And also it is used to predict actual prediction. This is a anomalous correlation of sea surface temperature, global sea surface temperature. Blue, magenta here means useful. So we have predictions that go beyond the weather scope. We go to 10 days and 30 days. In this case, 90 days after the month of the initial conditions. Next, please. And this is, I needed to show you that we have just completed the latest version of the BAS model that coupled atmospheric models from CPTech with MOM6, which is an actual next generation of ocean modeling. MOM6 is also going to be a little bit out of focus here, but I hope that everybody else is looking at here. This is a 3-year run of the fully coupled model, and this is just the average. We see the upper level circulation. That is one of the metrics to know whether or not we are modeling planet Earth. And then come two other figures. The next slide, please. So to show you what we are developing in terms of this concept of oil spill. So we are developing a high resolution coupled ocean atmosphere model at INPE, which is MOM6 regional with the ADA model. And we integrate this long lead predictions of high resolution ocean currents, temperature, salinity, chlorophyll into forecast oil, many forecast oil spill. In next one more, please. Click. to assimilate, and this is something that we are very excited about, is to integrate satellite imageries that are polar orbit satellites that often goes along and recursively cover a long area with our geophysical biogeochemistry model. One next, please. And to say that BES is an open source community developed model. So the model is available, and all the forecasts that we do operational every day from day 30 days are available in this concept of a community developed product. And then I will show two examples of what I mean by this. Next slide, please. One is this part of our project funded by the Navy in the CNPq project call for proposal 6/2020, that is get chlorophyll measurements or ocean color measurements from polar orbit satellites and integrate with our simulations of chlorophyll from our model to generate an hourly field of chlorophyll, for instance, to detect false positives and not false positives of oil detection and ship detections. The next, please, is next to the, yeah. And the other thing is that we intend with this effort to be able to detect and forecast rogue ships, dark ships that are not communicating they are what they are, and so that we can have a way to prevent and know that wrongdoers would do wrong things in other beaches, not along our coast. Next, please. And essentially, that's what I wanted to tell you, that we have this envelope of global and regional high-resolution modeling infrastructure that we want to make available for the whole community. Thank you.
Thank you very much, Dr. Paulo Nobre, for the very impressive results from the modeling. It's an opportunity to discuss about it later. Now I will invite Dr. Giulio Pellegrini for his presentation. Giulio Pellegrini is an oceanographer, doctor in science by the Rio de Janeiro State University, acting as a consultant for over 20 years. Since 2018, he has been the general director of the environmental consulting company Pro Oceano. He has worked on several environment studies and projects related to oil and gas activities and other applications. Recently, he coordinated the Costa Norte project, a multi-interdisciplinary R&D initiative focused on the vulnerability assessment of mangroves. Please, Dr. Pellegrini.
Hello, everyone. Thanks, Segen, for the introduction. A little bit about the concept of this project is an R&D project that was designed since 2015, because on the 2013 the Brazilian government decided to offer the Brazilian equatorial margin for oil and gas exploration and production activities to increase the activities on that region. As you may know, it's a very complex region in terms of oceanographic conditions, but also in terms of the ecological aspects on the coastal zone. That's why we are thinking and designing about a project that could be that could increase the knowledge on this region. It was funded by Enauta, is an oil company, under the special participation law from the Brazilian Petroleum Agency. The main objective of the project was to understand the vulnerability of mangrove forests, not just on the sensitivity and susceptibility aspects, but including resilience on the equation to understand the vulnerability. But some specific objectives. That was the characteristics of the mangrove forests in terms of quantitative parameters, and also to consolidate a conceptual framework, reducing subjectivity in the analysis of the vulnerability of these systems. And in the end, we'd like to contribute with the efforts on the contingency systems and actions. What's the challenges to work and understand these regions? First of all, the multiple scales involved. We were talking about hundreds of kilometers on the offshore region, and hundreds of meters on the estuaries, but also few meters on the tidal plains and channels inside these systems. On the other component, on the ecological part, we needed to understand if the mangrove forest was something homogeneous on the region or different, and we know that the systems are different. So we chose 4 different sites to study, to analyze the characteristics in Sucuriju, in Amapá State, São Caetano de Odivelas, and Souri in Pará State, and Turiaçu Bay in Maranhão State. To go to this approach, we structured the project in 4 main modules on the characterization of the mangrove forests, with the contribution of the State University of Rio de Janeiro and the Environmental Protection Institute of Amapá State. For the spatialization of the phytophysiognomies, we count on the support of again the same lab and the Rio de Janeiro State University, but also the Espaço lab from the Federal University of Rio de Janeiro. In the remote sensing, we were counting on the lab SAR for the regional scale, and again Espaço lab for the high resolution analysis. For numerical modeling, the responsible was on the LANCE from the Federal University of Rio de Janeiro for regional hydrodynamics, and LAPMAR from the Federal University of Pará. And for the oil dispersion, Porciano was responsible for the simulations. And for the oceanographic data collection, also offshore and estuarine efforts, LAPMAR was involved with the field campaigns. It's a good example of the application of the triple helix concept when you have a private company working together with different institutions, public institutions, and government on the other side, because the funding came not just from the oil company, but in the end of the day, from the Brazilian Petroleum Agency. We count with 71 researchers involved during the whole project. Some numbers of the project. These researchers came from 3 universities, 5 labs, 1 research institute, 1 oceanography company. In terms of the in situ campaigns, 150 days of mangrove campaigns, 121 days on estuarine, 152 days on offshore campaigns, 347 stations of measurements in mangrove forests. Until now, we have 18 articles, 10 academic conclusions, and some huge region covered by hydrodynamic modeling, but also LiDAR surveys, satellite image coverage, and satellite cross-satellite survey coverage. For the characterization of the mangrove forest, the campaign started in June 2017 until November 2019. In the 4 site studies with measurements on the forest, but also on the tide measurements and LiDAR campaigns. It's a huge effort to cover these 4 sites. On the oceanographic campaigns offshore, they started in February 2018 until February 2019. And was deployed 144 drifters of 3 different models covering the surface drifted, but also the subsurface currents in 6 different coordinates to cover the Pará-Maranhão and Foz do Amazonas basins, which were the focus of the project. These efforts with monthly campaigns for 1 year was made for the first time in the region. By doing these efforts during the whole year, we were able to identify with the drifters and compare with the hydrodynamic models some interesting phenomenon, like the inversion of the surface currents on the region. In the estuarine campaigns, the efforts were from 2017 until 2019. a lot of parameters collected in the four systems studied: bathymetry, currents, tides, temperature, salinity measurements, stability measurements, to calibrate and validate the estuarine models. In the remote sensing efforts, we covered more than 85,000 square kilometers on the mesoscale assessments, and on the high resolution image from the coastal areas. It was important to determine the limits of the mangrove forest in the system. It's a huge effort in the whole region that contributes a lot for the knowledge of the coverage of the systems on the region. And we also worked with LiDAR. It was fundamental to understand the flooding areas on the mangrove zones. It was, I would say, mandatory for the approach of the resilience that we were focusing on the vulnerability methodology. So with new techniques involving remote sensing studies to identify the species and crossing the LiDAR results, we were able to produce new maps from the coverage of the forest. That was interesting to understand different levels of sensibility on the system. In terms of hydrodynamic modeling, the first effort
to conclude in 2 minutes, please.
Okay, thanks. We have a 10 years numerical modeling basis for the region. It was important to produce the downscaling, the nesting exercise with new grids until the variable resolution inside the estuarine zones. Again, it was for the first time that a dynamic base was produced considering data assimilation on the region. The method utilized was the 4D VAR. In the local scale, it was very, very important to consider the LiDAR, as I already mentioned, to understand the flooding areas and produce this kind of results on the 4 study areas. Then we used this hydrodynamic model to do oil dispersion modeling. It was for the first time that a dispersion model online was offered and developed with different skills that could be used for the community. Again, we consider a multiple leak source to understand the susceptibility of the faults in different levels, not just on maps, but on a website platform. It was interesting to identify, for instance, inverse analysis methodology, considering a specific area and understanding the points that of oil spill that could reach a specific zone. All of these efforts, it was implemented to change the way that we analyze the vulnerability, considering maps with sometimes no optimal resolution, to a different combination of scenarios, considering sensitivity, resilience, susceptibility, and the final the vulnerability of these systems, not just on maps, but on a web platform that could simulate different periods, different types of oil spill, different contingent actions, and with a deep understanding on the mangrove systems. That was basically the idea of the Costa Norte project. Thank you.
Thank you very much, Dr. Julio Pellegrini. It was a very interesting, robust R&D project for the North region. I think we will have chance in the future to have more discussion about the methodology and how to use it in other areas, for sure. Thank you very much.
Thank you.
Now I'd like to ask Professor Alexander Turra for his presentation. Professor Alexander Turra is at the Oceanographic Institute of the University of São Paulo and coordinator of the UNESCO Chair on Ocean Sustainability, based at the Oceanographic Institute and the Institute of Advanced Studies at the University of São Paulo. Biologist with a master and PhD in ecology from the State University of Campinas, he has interdisciplinary and integrated scientific approach on themes such as marine biodiversity, governance, integrated management, marine conservation, and environment impact, including climate change and marine pollution. Please, Professor Alexander Turra.
Thank you, Segen. Thank you for the introduction. Thank you for the fantastic presentations and the efforts that were shared with us in this session. I would like to acknowledge and thanks Guilherme for putting us together, and José Moutinho for putting all together in this session in the Air Center, which is a very important initiative that is pushing several issues, several themes, several movements in the Atlantic. So it's a pleasure to be here. I will share with you some ideas and some thoughts and some initiatives of the network for monitoring coastal benthic habitats in Brazil, the ReBentos. I will share my screen right now and make a very brief presentation to you. Okay, just a second. You can probably see my screen, and now I will present, and probably you can see my first slide.
Yes.
Okay, thank you. So as Segen mentioned, I am here representing the University of São Paulo, the Oceanographic Institute, and the UNESCO Chair on Ocean Sustainability. And I would like to talk about the network for monitoring coastal benthic habitats, the ReBentos network that was built in 2010, and then it grew up and integrated a lot of scientists, institutions, coastal states in Brazil and different countries. This network had a very sensitive aim, which was to create and implement an integrated network to study coastal benthic habitats along the Brazilian coast, to establish basic information on biodiversity. So we are talking about long time series on benthic biodiversity as a strategic or a strategy to detect the effects of global climate changes. In the meantime, it's also helpful to understand the effects of local changes on the biodiversity too. So this is a joint effort to understand what's going on with biodiversity and how we can solve and modify the future of these habitats. There were some goals. One was to stimulate a thematic discussion related to climate changes. So the benthic community in Brazil was not necessarily focusing on this issue, and then Rebentos helped to divert the focus of the community to this issue. And then, as you see in a few slides, we produced a lot of documents in which we exercised this idea, and several efforts, several projects unfolded from this initial effort. Another goal was to establish long time series on biodiversity of benthic coastal habitats, produce knowledge to evaluate the effect of global climate changes and local impacts, because they are working together, to build capacity in Brazil, and to work on strategies of environmental education and communication of the Brazilian biodiversity and also its relationship with climate changes. Talking about numbers, we have about 166 participants in the network, representing 57 institutions along all the 17 coastal states in Brazil, and also including some international institutions. We also engage some governmental partners like the Instituto Chico Mendes para a Preservação da Biodiversidade, ICMBio. The strategy of the network of Rebentos was to work to have working groups focused on different habitats like vegetated soft bottoms, sandy beaches, rock shores, mangroves and salt marshes, rhodolite beds, coral reefs, estuaries, and also environmental education. We expanded Rebentos a little bit to focus on deep sea habitats, so it's not necessarily coastal, but we now have an approach on deep sea, and we are also focusing on a specific issue, which is marine litter that is extremely relevant recently. Some of the results of the network was the production of this electronic book with protocols, like guidelines for monitoring of benthic environments. So the community joined and discussed what would be the methods and the strategies to have this kind of long-term monitoring of biology of the coastal benthic habitats. And then we have in this book the protocols, the guidelines to do that. So it was produced by the whole community. We also created this special issue in the Brazilian Journal of Oceanography, which is now being called Coastal and Ocean Research. The name changed. And this special issue brought several reviews on the state of art, on what was known, on the biodiversity, on the relationship between biodiversity and climate changes, considering the different habitats. And it's open access and easy to identify or to reach this publication. It's really important and one of the most cited papers of the journal, because it really presented a very broad overview of these habitats of what was known at that time. We are talking about 2016. This is an ongoing result of the project of Ribentos. We created a Springer series on Brazilian marine biodiversity. We have 10 books to come. We already have 3: Brazilian estuaries, coastal and marine environment education, and Brazilian deep sea biodiversity. The next 2 would be focusing on mangroves and salt marshes, and the other one on sandy beaches. And this is important because it goes beyond the review paper we published in the special issue, and now we have a way to show the works that are being done here in Brazil, and to show what we have in terms of benthic habitats to the international scientific community, so that we can improve our collaboration and study a little bit more our environments. So we have 37 monitoring sites in this area representing different habitats. It's a growing movement. We need to engage more universities, more researchers, more habitats, so that we will have a broad overview of what's going on with these communities. Communication is a very important aspect of Ribentos. We are trying to communicate what we are discovering in the studies we are conducting, and we are using the webpage that you can look at. There are several papers. It's in Portuguese, unfortunately, but for the Portuguese-speaking community, it has been a nice and good reference of what's being done in these habitats. There are some potentials, and I'm almost finalizing related to Ribentos. One relates to the adaptation measures to climate changes through monitoring and evaluation of the effects of benthic community. So one of the adaptation measures to climate change is to understand what's going on. So monitoring and evaluating the effects of the changes in the benthic communities is a very important measure that needs to be fostered and supported. We need to apply these protocols. We may also apply these protocols to record exotic species, which is an additional achievement of the monitoring efforts. We also need to integrate a little bit better with marine protected areas, so that we can expand the monitoring initiatives to areas that need to understand what's going on there, like marine protected areas. We also need to improve or to increase the awareness of society and decision makers about the importance of marine biodiversity, ecosystem services, and impact of climate changes on human well-being. And this is being done right now because we are creating here in Brazil report, an assessment of the marine and coastal zone following the strategy of the Intergovernmental Platform on Biodiversity and Ecosystem Services, the IPBS. So we have here in Brazil the BPBS, the Brazilian Platform on Biodiversity and Ecosystem Services. And now we are doing that to understand or to systematize what's happening with biodiversity, and not only the organisms, but also the benefits that biodiversity brings to society. And also we need to stimulate the integration between different areas of knowledge, and then we need to emphasize the need to a better match, a better integration between the biological sciences and the physical sciences, but also between the natural sciences and the social sciences, which is extremely relevant to overcome the problems that are facing the coastal zone. We need to understand what are our challenges, our needs. There are some documents that are doing that. One was published some years ago in Global Change Biology, emphasizing the need of support, the need of continued support, as Guilherme told us this some time ago. And this is really important because we need to have a strategy to have the science we need for the ocean we want to have. And this week we had the launching of this document produced by the Brazilian Academy of Science, supporting dedicate of the ocean in terms of emphasizing the needs we have in Brazil and the challenge we need to overcome. So this is an important aspect because the Brazilian Academy of Science has a strong role in pushing the scientific movement here in Brazil. And in the end, I'd like to mention that we did that. We are doing that with partners. We are talking about universities. We are talking about funding agencies, organizations like the Climate Network. That is a very important arrangement, institutional arrangement that's still in place here in Brazil. And that's one of good example that may be followed in future initiatives, because it's a state policy that is helping us to keep going with such initiatives. So thank you very much, Segen. Hope I did not advance it in time. And here is my contact if you would like to talk later. Thank you.
Thank you very much, Professor Alexander Turra, for the nice presentation about the Rebento network. Quite interesting. I would like to call now the last speaker, the last but not least. Yeah, Dr. Carlos Leandro da Silva Jr. for his presentation. Carlos Leandro has a BS in Oceanography from the State University of Rio de Janeiro, MSc in Remote Sensing applied to Oceanography from the National Institute for Space Research, specialization in air-sea transfer process from the University of Washington, Seattle, and has a very large professional experience in remote sensing division of the National Space Institute, also a CEO of the OceanSat Space Technology for Environmental Monitoring, Market Director of OceanSat PEG, and also Partner Director of Ambipetro. He is now currently coordinating the Kronos project, which is a platform that integrates meteosonographic data from different sources at Ocean Park Maritime Services. Please, Dr. Leandro.
Thanks, Segen. Good morning, everybody. It's a very pleasure to stay here to talk about the Kronos platform. Okay, I just share my slides. And let's see here. Okay, guys. Oops. You see? Everybody seeing the yes. Slide? Yes. Okay. Right. Okay, guys, let's go. The financing of Kronos platform is by FINEP. Is classify a pioneer innovation. Is a strategic innovation, in that case, plans. Okay, and a high degree of innovation and relevant for the economic sector, especially in our case, the oil and gas industry. Is our logotype of the Kronos. Okay, in order to have an idea, the time frame between identifying some kind of incident and you have a good operation or response in order to fix everything. Okay, that's is begin the activity. Kronos project sign a strategic partnership of the Brazilian Navy, in special of the Instituto de Estudos do Mar Almirante Paulo Nobre, lá em Arraial do Cabo, e o Centro de Auxílio à Navegação Almirante Moraes Rego, Okay, com o objetivo, sorry, one of the objectives of these partnerships to improve the ocean monitoring and the strategy part of the Blue Amazon. The goal of Kronos platform is about reduce the time frame between the incident detection and the effective response, and the oil spill response in certain rescue operation. Oops, sorry. And of course, the intelligence data in the cut edge for that move oil and gas industry toward safety operation. That's after many accidents around the world, including Brazil, we need to look for these goals in terms of the oil and gas industry. Offshore operation windows developed in the case of the Kronos, the idea to create windows to operate windows in order to give safety for the people operating this area, the offshore area. The concept Kronos is a platform that integrates metocean data from different sources. The main innovation is use the 2D surface current maps obtained by high frequency radar data in near real time to integrate other data collected remotely and situ data. Okay, Kronos platform maintain an up-to-date operating system prepared to assimilate and generate reliable hydrodynamic modeling, allowing to simulate different types of drift from the oil spill on any object on the surface of the ocean. The different Kronos platform, different integrate data, exactly I said before. And you have the AGF, satellite data, in situ data by vessels, glider, and different buoys. You have the modeling area, the data analysis, and the integration visualization, all the information in the special place in our company, okay? Kronos areas is coverage campus and the parts of the Santos Basin and the Espírito Santo Basin also. We have three, in the first phase, of course, we have three radar, AGF radar station. One in Itaipuaçu, called Site Frio, Site Itaí, Site Tomé, and the Site Frio. This is more strategy site for us. This is a view of our station in the Itaipuaçu. You have all the system integrated inside of the station. You have three kinds of antennas: a reception antenna, this one, a two transmitter antenna. And the same happened in another site, of course, is in Tomé, Cape of São Tomé, in north of Brazil. The same configuration. And in our case, more important is Frio Station, because you have a view from the one point, you can see, you can generate data from the Santos and the Campos Basin. Yeah? You install this station in the top of the mountain in front of the ocean, the cliff here. This is a view from the station. You have a shelter, and then put all the electronic system, have a man solar panels, have antennas, have a view, in that case, from drone, a view from the drone, and the overview of the station. This is a kind of hybrid wind and the solar system in order to generate energy for the system, because over there isn't any kind of energy, you know. Then that case, you have some wind turbine, solar panels, you know, batteries, generator, just in case you need to use it, inverter of the charge and the charge inside of the system. This is a view inside of the shelter. This is another view. The antenna is a very, very interesting place. Some results about that. We inaugurated the Kronos project in last June. And here's we have an overview of the cover of the AGF radar data in the area. Okay, this is inside of our system. We have a system called Portos, and the Portos integrates, it's like our portal. We integrate different kinds of data. For example, AGF radar, mathematical modeling, satellite data, data from, for example, our fleet. You have a fleet, the company have a fleet and collect the wind data every day and transmit for our integrate the system. In that case, a port system. You have some features, sonograph feature here. Is another kind of data, just to have an idea. When you click here, you can see all the information about the vector of the current. Is another view of this, is some vortices, you know. Here is exactly one paper, you just to compare what's happening here in the July 1973 by Signorini. Is a very interesting because the guy made a lot of hydrographic station. He used a thermograph in that time, of course. And when you compare today, you can see the same feature in the same place. Yeah, you have a anticyclonic edge over here. Then you can see the same feature in the area. And in July 11, you have a presence the dipole here, another one here, cyclonic and anticyclonic eddy. And in the second case study, you have a cold front cross the area, then you have the satellite data before the cold front arrive in our area, then to have a good result, you have a simulated, just to see, not simulated, this is a kind of a sequence of the image, the data. Then you can see here the Brazil current here, the axis of the Brazil current in this way. And you can see in this area, you just move it after they cross the area or the cold front, the direction of the current move almost immediately, you know, in this area. That's very important. The first time you can see this kind of phenomenon like that, like you know, you see in the movie and you can measure it. There you see the acceleration of this current. Yeah, here is decrease of the Brazil current intensity. That's a kind of data is generated every day in the Chronos, you know. That's very important for us. The second case, you have the same situation, okay, the change in the direction of the current. Then you can combine of satellite image also, you know. That's very nice. You generate a lot of data now, and you have receive every day SST maps, wind on surface, sea surface, and sea surf high, and geostrophic current in the region. That you can compare the data in case of geostrophic with the CODA data. You can see the same feature here, like a Brazil current in this way, the vortice, and the Brazil current in this way, okay? And we launch also Lagrange drifters. You have a partnership of the Meloa Consortium by the people from University of Portugal. Glider, we launched glider in the region, sea glider system, and use a DCP of our some, not all, but the part of the fleet has at least 2 ADCPs on the rule. And we have a partnership of Lance, Federal University of Rio de Janeiro, for the part of numeric modeling for assimilating data, included the CODA data. That's an area of the domain of our modeling. And here's the area of Chronos. You have an interest specific in this area. This idea exactly we have today. And the principal point you want to talk about exactly to assimilate the AGF radar in Brazil for first time. People has assimilated different kinds of data like SST, salinity, any kind of data. But in first time Brazil, you assimilate AGF radar. This is a kind of data you can compare. For example, when you compare the data, for example, you measure the data, you compare, for example, the modeling data, you have specific difference between the one data measurement and the just prediction by modeling. And the idea to assimilate this kind of information and create a new generation of the modeling in Brazil. And we have WaveWatch 3 also. We provide this kind of data inside of the platform. And of course, in the part of the team developed a specific oil model, open source. In that case, you use the open drift for do that, and compare of the Oscar is a very expensive model. And the most of people use this kind of model. The idea exactly to have a new, not new, but a model can, for example, share all the community. You don't need to pay for the Oscar because it's very expensive. This is our room. Kronos room is an environment that you receive all the data, including the platform we talk about, and the people there can make a good decision about what's happened on the field or in kind of accident you have, And this idea because today you have 3 stations. We have a Frio, Itaipuaçu, and Cabo de Santo Tomé. The next step increase for west, more 2 stations, and for north, more 2 stations also, and increase all the coverage area. That's the idea. This we have in this year, we carry out.
Leandro.
What?
Please conclude.
Okay, that's almost my last slide. This is a vessel, okay, using this experiment for in situ data. Yeah, we have accommodation for many people, many research. The ideas included to invite some guys, some universities, research institute to participate in this experiment in our area, exactly to have idea what's happening with the CODA data and the water column in order to calibrate and validation our modeling. Okay, these are our last, the first, in fact, publication, our team. The people has a high producing in terms of the results. And that's it. Okay, thank you very much.
Thank you very much, Leandro, for the presentation. Very interesting, the platform. Of course, it could be enlarged and included other measurements in the near future. Thank you very much. Now we have time, not a long time, but about 20 minutes for discussion and questions. We have here already some questions. I will read them. But before that, I'd like to thank José Moutinho from Air Center for the invitation, organization, and support to this event. We have, in fact, 2-part events, one today and the next one next Friday. Thank you very much, Moutinho, for all the support. Now I pass to the questions, and I will read here, and some of them I've directed to some of the speakers. Like the first one, that is a question of $1 million. It goes to Carlos Lentini, this question. It's about the source of the oil spill that affected the Brazilian Northeast in 2019. $1 million.
Shall I answer in English or in Portuguese?
In English, I think it's maybe
okay.
It's better for the audience. If you
Thanks. Indeed, that's the $1 million question. We don't know. We have still we have a few candidates, as we all that are involved on this kind of research. This is a paper that is under construction right now, but we are also running some Lagrangian simulations test, one of our hypotheses. But at the same time, like what we need, it's the oil characteristics, the API characteristics of the oil. And that is something, that the oil companies, if they want, get together with us, with science, and especially, like with plans for mitigation, detection, and remediation, we should get together and have this kind of information. I know that most of them, they are, highly confidential, but like if you are thinking about, having the INMAR, the Institute of Mar, we need to do something like that. We need to discuss, to get together with these oil companies and discuss about that, because if you don't know the oil characteristics, it's kind of difficult for us also to feed our models and get, at least close answers to what we think happened. At the same time, what you need, is like computer power and at the same time musculature to get together, like, this brilliant opportunity that Guilherme, Franz, José Moutinho, and Maurício Nuemberg gave us to get together and work together, not as competitors, but as collaborators. Okay, so I think that INMAR, will help us with that. So in doing so, we can, like put all our efforts together, get the best out of each group, and then come up with, some good answers.
Thank you, Carlos, for your answer.
You're welcome.
In fact, I was wrong. We have almost 5 minutes left. Then I will ask all the speakers to answer as quick as possible. And if needed, we can give the contacts for further discussion. Okay, I'm sorry, but the time is running. There is a question to Professor Franz from Carlos Antonio about the combination of all the models presented in this morning or afternoon, in this network, if they are integrated in the observatory from the Brazilian observatory, and if could be used in the Benguela current. He also asked Professor Franz if there is a program for the formation dedicated to countries emergent economies. Please, 1 minute, Franz, please.
Thank you for the question. It's our intention to include more models along the Brazilian coast in the BSO. For instance, Karina present for us a model for the Guanabara Bay, that it's our intention to collaborate, to join efforts to optimize the research. And so it's not yet in the platform, but we wish in the future you can collaborate with more groups, local groups, to include more models and extend the number of models along the Brazilian coast. And as I mentioned during the presentation, the BSO, the platform, the code is open, as well as the code of the models, and you can replicate to other parts of the world. And we have now funds from projects, short lifespan projects, so they are restricted, the funds are restricted, and you need more support to expand to other parts of the world. And as I mentioned, our center can support this type of idea in the future.
Okay, thank you. There is a question from Mario-Lane Crook. It's about the choice of ROMS over Delft for modeling of embayments and coastal regions. I don't know if Franz or other speaker could answer. Why ROMS and not Delft for modeling? There is no name for directed to this question. I think it's
I can ask this question.
Okay, Karina, please.
At last, we have good results with ROMs in coastal areas, including river modeling. We also already use other models such as POM and MON. And ROM, it's a robust model, and our assessments in both coastal and oceanic waters have shown good results.
Thank you, Karina. There is a comment and question from Professor José Muibert. I will read here. Ocean and coastal observation and his use is an operational activity that requires continuous sustainable and long-term support for infrastructure, logistics, and personnel. Can an observation program within these characteristics be supported by academic short-term projects? It's a question. What is required to have a nationwide or Atlantic-wide sustainable, integrated, and operational ocean observing program? I think it's a very interesting comment and a challenge for all of us to integrate it in the country and also through the Atlantic. I think the answer for me, it's we should start by a national institute and then try to connect our efforts to the Africa and other countries. Thank you for the question and comment, Professor José Muibert. There is another question about I think to Paulo Nobre. I wonder how it simulates the South America monsoon variability. I'm from Asia, and I'm from Asian monsoon region, and understand it's very challenging for monsoons. It's from way down you, the question.
Thank you, Segen. Yes, predicting monsoon flows is a real challenge. And what we discover using our coupled ocean atmosphere model is that we need to have decoupling in order to explain, at least in South American monsoon, why it rains more over cold water, like the South Atlantic Convergence Zone. When it establishes during our summer, it's usually associated with cold SSTs. And this is not what would expect from a simple thermodynamic consideration. So my quick question for you is, improved coupled ocean atmosphere fluxes must be contemplated. Thank you.
There is another two questions for Paulo. Maybe he could answer later or next week. One is from Peter Klaus. Brilliant presentation, very impressed about the model, and asking about services and products from your model, Paulo.
Yes, we do operationally, we do sea surface temperature like ENSO forecast at INPE, and we do seasonal forecast of rainfall over the whole world, but focus on South America. And now we are gearing into high resolution coupled models in order to be able to predict beyond the weather, predict 10 days, 15, 30 days in, say, 1 kilometer to 5 kilometer coupled ocean atmosphere model.
And additional question from anonymous attendee. Does your model allow for the assimilation of biodiversity data?
Oh, this is a good question. This is the frontier of knowledge on climate change. We need to assimilate biodiversity. We need experts so that we have a dynamical vegetation model already there, but it is too simple. And biodiversity is an essential issue on predicting longer term changes in the ability of forests and ocean biogeochemistry to couple with, to deal with climate change. Very good question. So collaborations are welcome. My email at the end there, and can contact the advisors. It will be very much appreciated. Thank you.
There is a nice comment from Krista von Hillenbrand Andrade. Impressive and fascinating work, Brazil. Congratulations. On behalf of my colleagues, thank you very much. We appreciate it. Currently, there are only 3 stations that are available through the UNESCO EOC Sea Level Monitoring Facility and at the Pacific Tsunami Warning Center. If there were a tsunami like in 1755, which was generated in Portugal, but reached Brazil, the advisory service of PTWC for Brazil would be very limited. Open sea level data could also support other regional and global sea level monitoring and advisory service. What would be required for more data to be open and accessible in real time? If Paulo would like to say a few words about this.
Yes, please. Thank you. This is a crucial problem that requires international collaboration and cooperation. And I will give one example. The Pirata project over the Atlantic, tropical Atlantic, it's a 24-year project between Brazil, France, and the United States that maintain a network of 18 buoys. Now imagine this, with the 10-minute data, continuous 10-minute data for 20 years. So we need to enlarge it, we need to expand it. It is very expensive. And I have to congratulate the Brazilian Navy for the extraordinary work it has provided during all this time, but not only, all the partners, but for Brazil in particular, with very limited resources, that the commitment of the Navy to maintain this network. So we need to expand and, sorry for the delay, but the National Institute for Ocean, the INMAR, as Segen mentioned, in Brazil, is one capital and absolutely necessary way for Brazil to cooperate with the rest of the world. Thank you.
Thank you, Paulo. There is now a comment and question from Professor Monica Muelbert. Thank you all very much for the presentations. How is indigenous, traditional, and local knowledge being integrated in these monitoring initiatives as we enter the UN Decade for Sustainable Development? If Alexander Turra.
Yes, very brief. It's a very important source of information that is being considered in local, very local initiatives, but not in a wide strategy or in a wide program along the Brazilian coast. We need to face this important challenge and widen this type of dialogue along the Brazilian coast. This is an important challenge to be considered. Thank you, Moni.
Karina, would you like to comment about this?
No, I agree with Alexander.
Okay, that's fine. Anonymous attendees say, thank you, Dr. Bork. I will contact you. Be prepared. Okay, then Frederic Bono. Does BESM, this from Paulo Nobre, data are available in global scale? Does BESM data are available in global scale again? Does this model simulate waves parameters such as wave height, wave direction, and wave period? Paulo?
No, we don't have wave modeling yet. We are working to have the WW3, the Wave Watch Model 3, to incorporate, to modulate small scale and effects of wave interaction between ocean and atmosphere. So we don't, it's a limitation of our model, we recognize, but it's still to be included.
Okay, a question now to Leandro, Carlos Leandro, from Jerome Benveniste. Where do you get the SSH data from? Do you need SSH data closer to the coast? Sound, please, Leandro.
Okay. Oh, sorry. I received this kind of the data and all satellite data from the small company, the people creating São José dos Campos. People come from the National Institute for Space Research and mounted a small company that provide for us all this kind of satellite data. I don't have, for example, but in that case, you can buy, for example, the Aviso. Aviso can provide this kind of data. But in our case, we have a specific contract with the company to provide for us.
Okay, Mr. Benveniste suggests a site to have a look. Okay, then you can access, Leandro, and comment maybe next Friday.
Okay, thank you.
Eric Oliveira Ribeiro, congrats, Julio. It's a huge project, great human resource and goals. Were there any case of malaria and yellow fever in the team? He's asking about the problems with the team.
Yeah, field campaigns. Thanks for your question, Eric. No, thanks God, we had no disease on our team. And just remember, for the yellow fever, it's mandatory to have the vaccination to go to that region.
Okay, thank you. Another one for Paulo Nobre, the BESM data free to get? Asking, is free to get? What is data policy sharing?
Our data are freely available, and that's all I can say. It's freely available. Just write an email and I can direct for where the data is.
Okay. And there is, I think, the last question, anonymous attendee asking Guilherme Franz, but I think it's a general question. Thank you for a presentation. This is to Guilherme. Could you give more detail about the creation of the National Institute of the Sea?
I can say a few words about it. I think it's just a question of political will. So there is a plan from many years ago to create this National Institute, but you need to, why it's important to inform people about these initiatives, why people need to understand why it's important to monitor the coast, the ocean, to have this observation and the modeling systems, to press the politicians to create this institute. So you need to include, for instance, as I mentioned in my presentation, citizen science activities and inform public awareness, education, to press the politicians to create this institute. That is very important. I think Segen is who can say more about it.
Yeah, I can just to complement your comments. It's a process underway. I think we have two important stages already. One is the authorization of the Minister of Economy to open a call for entities to be qualified as a non-governmental institution to manage the actions related to the ocean. This is in progress. We are expecting a new call from the Minister of Science, Technology and Innovation for the selection of this institution. I would say that we are very close, but of course, it depends on the political will. And we hope that it can happen soon. That's my feeling. I think we finish answering the questions. I would like to thank you again, José Moutinho, for give us this opportunity to be here together and discussing initiatives from Brazil. And I thank you, the audience, for the interest. And I expect to see you again, all of you, next Friday for new 7 speakers to continue talking about the advances we get in Brazil about coastal observation and modeling systems. Thank you very much. Have a good day.
Thank you all.
Thank you.
Bye-bye.
Thank you. Bye-bye.
Bye-bye. See you all. Thank you so much.
Bye.
Ok, pessoal. Obrigado a todos.
Obrigado.
Muito obrigada.
Abraço.
Boa tarde a todos.
Boa tarde.
Todos. Tchau.
Tchau, tchau.
Tchau.